ABC placed on a smooth horizontal surface, students, such that the mass of A equal to mass of C is equal to 4 times mass of B. Okay. So there are 3 balls given to you, students. B is in between A and C. That's what they've given to you, students. I'll draw the diagram, students, first. Mass of A is equal to mass of C is equal to 4 times mass of B. Okay. So we can consider mass of B as M, students. Agreed? Therefore, mass of A will be 4M, mass of C will be 4M. Students, now your vision should be all the time over here. Ye clear hua, students? Mass of A is equal to mass of C is equal to 4 times mass of B. Mass of B को मैंने M ले लिया, students. So ये तो 4M हो जाएगा. Now they've given you, there are 3 objects, there are 3 spheres. Okay. A, B, and C. And they've shown the motion of B, students, with a velocity V. So given 3 balls A, B, C are placed on a smooth horizontal surface given the masses. Ball B collides with ball C with initial velocity U. The first collision, students, is B with C. So the first part we speak about, B colliding with C. Okay. With an initial velocity V as shown in the figure. So let us say U1 will be equal to V we consider in the figure. Find the total number of collisions between the balls. All collisions are elastic. So important part is collisions are elastic. And secondly, we consider is what? I need to find out number of collisions. How many collisions can occur in this case? Is this a question clear to all of your students?
Yes, sir.
थोड़ा सा अगर ध्यान से पेशेंस से करोगे ना, और आई एम टेलिंग यू वेरी क्लियरली, अगर यू ट्राई टू गो फॉर योर बेसिक्स, जो भी तुमने बेसिक समझा है ना, द प्रॉब्लम इज एंटायरली ऑन टू दैट, लेकिन it is calculated, थोड़ा सा lengthy, and since the variables are a lot, students tend to commit mistakes. The problem is easy to crack it. It is lengthier, but it simply goes on to your basic concepts. Anyone who can tell me how to go about with it? What is your approach? Swani has raised hand. Anybody else? Chanani, what about you? You missed out the lectures also yesterday. Krati?
Sir, yes, sir, I'm doing it, sir.
Yeah. Krati, what about you? Om, you were not present yesterday.
Sir, trying.
Okay. Partwit, try it out. Sanjana.
Yes,
Kya
sir.
baat hai? Saud is present today. साउथ आज स्कूल्स नहीं है क्या तुम्हारे? मंडे से स्कूल शुरू होने वाली थी ना, कॉलेजेस? साउथ, साउथ, are you there? Saud, are you there? He's not there. Oh, because of yesterday has just entered in. He has kept his everything
Sir, I didn't get the exact answer, but I think I have an approach to find it.
Sanjana, you are answering?
Yes, sir.
Okay, wait a minute. What about Soumya? Still you are in native only, Soumya? कल थे ही नहीं तुम? हाँ, Soumya? Shreyash, even you were not there yesterday. No need to text in that case. You should unmute yourself. Udit was also not there. Gauri was also not there. Sparsh, even you were not there. It was only Yana who was present. Vidhi Parmar, are you there in the lectures? You are not there in the lectures. Okay, 3 students have got it. Suhani, Chanani, and Sneha. Yes, Chanani, can you answer? Janani, you want to answer? हाँ बोलो क्या करोगे?
Sir, so we have to find the number of collisions, right?
Yes.
Sir, actually, I don't know how to explain, put this into words, but I got the answer.
What answer you got it?
Is it 2?
अरे क्या बात है? So see, what is to be put in words? You put in words, number of collisions are 2. You
Yeah,
said you can't.
the answer is number of collisions are 2.
Yes, but my question is, what is your approach?
Sir, actually, like, so just to, sir, I don't know how to explain this, but velocity of B is equal to mass of B minus mass of C into B plus mass of C the whole by B.
Oh my God. ये कहाँ से?
So that's why I don't know how to put it in, I don't know how to explain it.
My dear, if you have done it, it's very easy. I told you there are basic formulas used. मैंने अभी बोला problem lengthy शायद तुम्हें दिखेगा लेकिन it's very easy. Just go on and don't try to. If you students anywhere, if you're trying to look into it also, don't look out at the solution. To hell with it and just go on to your instincts. You'll be getting it by yourself. Yes, Sanjana, can you tell me how it is the approach?
Sir, I tried finding the velocities of particles
Okay.
by m1 minus m2 u1 upon m1 plus m2 formula.
Hmm.
So
Means you
after that,
use law of conservation of momentum.
yes, sir.
Okay.
So one of the velocities was coming in negative direction. So it means it would again collide with A. So total collisions would be 2.
Okay, 2.
Yes, sir.
Okay, fine. Anybody else? Anybody else who wants to answer? Parthy, what about you? You want to answer?
So can I answer?
Can I answer?
Now, Suhani wants to answer. Suhani, you'll be the last one to be picked up. Don't worry. Okay, Suhani? Sneha, can you?
Yes, sir.
Bolo?
Sir,
Sneha, I'm not able to hear you.
sir, can you hear me?
Yeah, yes. Tell me.
Yes, sir. So for the B and C collision, I found the final velocity of B first using the formula V1 is equal to M1 minus M2 divided by M1 plus M2 into V plus 2 M1 into U2, sorry, 2 M2 into U2 divided by M1 plus M2. And I found out the velocity of the final velocity of B to be minus 3 by 5 V meter per second. So it will
Okay.
collide with A again. and C will get a velocity towards the positive direction, which would be equal to 2 by 5 v meter per second, using the same formula.
How did you get the velocity of C?
So I use the formula, same formula, m2 minus m1 divided by m1 plus m2 into u2 plus 2 m1 v1, sorry, u1 divided by m1 plus m2.
Okay, fine.
So, and then for the collision of B and A, I again use the formula. Here, the initial velocity of B would be minus 3 by v meter per second. So I found out the final velocity of B to be 9 by 25 v towards the positive x direction, and the velocity of A would be minus 6 v by 25 meter per second, which is towards the negative x direction. So, sir, in the second case also, if we see the velocity of P is quite less, so it cannot have another collision with C also.
Absolutely correct. What about you, Suhani? You have done the same thing?
Yes, sir, I've done the same thing.
Okay, I knew that you will get it.
But after the second collision, the velocity of B becomes very less, so it will not collide with C again.
When you solve it, it will be 0.4 and 0.36, so it cannot catch.
Yes, sir.
Yes.
Okay, यानी C आगे भाग रहा है 0.4 मीटर पर सेकंड से, और C पीछे उसके पीछे जा रहा है वो 0.36, लेकिन वो पकड़ नहीं पाएगा उसको, इसलिए वो कोलाइड नहीं हो रहा है. Very good. Students, Yana, did you get it, Yana? What exactly these three girls were speaking about? Yana, are you there? Knock, knock.
Yes. Yes, actually, I got both the velocities positive.
Which velocities you got the positive? V1 and V2?
The velocity. Now, velocity of B, final velocity of B and C. So only one collision can take place.
Let me put forward the formula now. Please pay attention, students. Let me put the formula. Okay. Now, please pay attention. The formula. Let me put forward the formula for V1 and V2 first. Students, everybody should know the two formulas. Students, velocities of the bodies after collision. V1 is m1 minus m2. Students, please look into it. M1 minus m2 into what exactly? Consider u1 upon m1 plus m2. Agreed? Plus 2m2 into u2 upon m1 plus m2. Final velocity of the second body after collision, students. ये formulas तुम use करने वाला, students. V2 will be equal to what? Will be m2 minus m1. यहाँ पे u1 है तो यहाँ पे क्या आएगा? u2 upon m1 plus m2. Again with positive sign. 2m1. This will be u1 upon m1 plus m2, students. Now, Yana, tell me, did you use these two formulas?
Yes, I used the same two formulas.
Okay, now please pay attention, students. Let us go for the way Yana has saying it, okay? It was said that B was colliding with it. Students, when B was colliding with C, students, इसका initial velocity 0 है, इसका initial velocity V है, हमें इसका final velocity चाहिए और इसका final velocity चाहिए, तो दोनों का आंसर तो पॉजिटिव में ही आएगा ना, कि नहीं? हाँ, is it? नहीं.
गर्म पानी क्या कर लो जाके. तो आपकी चप्पल कहाँ ठंडा है पर?
अदिति के चप्पल ठंडे हैं. Oh my God. अदिति के चप्पल.
So sorry, sir.
अरे अदिति के चप्पल ठंडे हैं.
I'm so sorry, sir. I was not even knowing that the mic was on.
Very good. इसमें ठंडी है. Okay, students.
How did you know, sir?
It's everything is fair in physics. Okay, come back. अब यहाँ पे देखो V1 की velocity क्या होगी, students? After hitting, B will move and it will recoil backward, students. It will recoil backward in this case. So now in this case, what exactly I'll consider will be your velocity of the body after sorry, this is U2. I'll consider this is U2. Are you getting it? U1 and U2, students. Is that clear? Now, if I happen to consider what exactly the velocities I'm going to get it, how am I going to get the velocities? Students, ये जब भी बॉडी कोलाइ करेगा तो दिस इज इनिशियल वेलोसिटी u1, its का initial velocity is 0. After collision, what happens in this case? B will recoil backward. Are you getting it? So how do you go about with this? Yes, Yana, what did you do now from here onwards? Did you find out V1? What is M1 over here? Students, what is M1 over here? M1 will be mass of B. M2 will be equal to what? Mass of C. And what is mass of B? M. Mass of C, 4M. क्या ये clear हुआ?
Yes, sir.
Now can I find out V1? अभी है ना, देखो तुम्हें पॉजिटिव मिल रहा है, नेगेटिव में मिल रहा है. स्टूडेंट्स, ये मैंने बोला ना, ये था इजी है ना, यू कुड हैव गॉट इट वेरी इजीली. लेकिन मैंने बोला वेरिएबल्स पूरा प्रॉब्लम कर रहा है. ये वेरिएबल्स का पूरा गेम है. स्टूडेंट्स अगर
मैंने
थोड़ा
मास ऑफ सी, मैंने मास ऑफ सी को m लिया और मास ऑफ बी को 4m लिया.
ऐसे कैसे होगा? मास ऑफ सी इज 4 टाइम्स, तो जो स्मॉलर मास होगा उसको तुम m लोगे ना. मास ऑफ b विल बी m, therefore c विल बी 4 टाइम्स m and a विल बी 4 टाइम्स m. तुमने वहां पे गड़बड़ कर दी थी. तुमने इसको ध्यान से देखा ही नहीं. अभी तुम्हारा ये देखो, तुम्हारा ये मेरे साथ में मैच नहीं होगा, है ना. अभी देखो मैं V1 निकाल रहा हूँ. फ्रेंड्स, V1 के अंदर देखो, अगर मैं V1 लिया तो व्हाट इज U2 ओवर हियर? तो बोले सर U2 तो 0 है, तो ये पार्ट तो 0 आएगा, latter पार्ट तो 0 हो जाएगा. एग्रीड. तो नाउ कैन आई से M1 minus M2, how much is M1 sir? M1 is M minus M2 sir, M2 is 4M into U1, and U1 is V upon M1 plus M2. M1 plus M2 यानी M plus 4M, और पीछे का पोर्शन तो 0 हो जाएगा. क्यों 0 हो जाएगा? क्योंकि U2 0 है स्टूडेंट्स. So what exactly my answer will be? So this is minus 3mv upon 5m. M gets cancelled. So what is the velocity of B? We consider minus 3v by 5. Is this clear, students?
Yes, sir.
और ये क्या है? Final velocity of V, students. That means this is final velocity of B, and it reverses its direction. Agreed? अभी हम क्या करेंगे? C की भी फाइनली फाइंड आउट कर देते हैं स्टूडेंट्स, क्योंकि C तो आगे की तरफ जाएगा. B कोलिजन के बाद में रिवर्स जाएगा, लेकिन C तो आगे जाएगा विद द वेलोसिटी V2. लेट अस फाइंड आउट V2. तो V2 का फॉर्मूला क्या होगा? M2 minus M1. व्हाट इज M2? 4M minus M1 is M upon 4M plus M into U2. How much is U2? U2 is 0. तो ये पूरा फैक्टर 0 हो गया. प्लस 2 into M1. How much is M1? Is M into U1, and U1 is V upon M1 plus M2. So that will be M plus 4M. So what is the answer for this will be? This will be 2mv by 5m. So now can I say, what is the velocity of C? Velocity of C. ध्यान से देखना students. ये V2 है. V2 is nothing but velocity of C, and that is moving in forward direction with how much? ये है students velocity of C. Forward. 2 by 5 means can I say 0.4 times V. क्या ये clear हुआ सबको? B is hitting C. C is going in the forward direction. B is going in the backward direction. What is the backward direction of B? Minus 3V by 5. C will be 0.4 times V. Is this clear?
Yes, sir.
All of you all, it's not only 2 or 3. Parthi, are you getting it? Chati, are you
Yes,
getting it? Suhani,
Yes.
Yes, sir.
Vidhi Parmar, you're still not replying. Vidhi Parmar, you're not. Vidhi Parmar, you're not replying.
Sir, you are on mute.
Now students, B is going in this direction. Okay, and what is the velocity of B? It's minus 3/5B. Agreed. A is at rest. Now I'll consider this as U1 students. U2 is at rest. Can I find out V1 after collision and V2 after collision between A and B? What is mass of B? Students, mass of B, I'll consider that as M1. What is mass of B? Is M. ये B का है. Agreed. What is mass of A? I'll take it as 2. And what is mass of A? 4m. This becomes my information. I need to get V2 and V1. ये दोनों चाहिए मुझे. Friends, is the data clear with you?
Yes, sir.
Now can I use the same formulas to get the answer? Let us find out again. Velocity V1. If I use the same formula, students, now we are going for this part of it, not this part. Now B moving towards A, because after hitting, C is going in the forward direction with 0.4. B is going in the backward direction with 3/5B. Agreed? We can take it as negative. Now I'll go for V1. Now when I go for V1, what exactly the value of U2 is? U2 is 0, so the latter part will be 0. यानी ये तो लेना ही नहीं है, plus 0 आ जाएगा यहाँ पे. लेकिन ये क्या होगा? M1 minus M2. How much is M1? M. Agreed. Minus M2. M2 is how much given to us? 4M. Agreed. What is U1? U1 is minus 3V/5. This is important. Students, this is B colliding with A. When B collides with A with an initial velocity of minus 3/5V, after collision, what is the velocity of B? वो hit होके इस तरफ आएगा. यानी after hitting, B will try to move along positive x-axis. तुम्हारा V1 positive में ही आएगा. Now see, am I getting positive? Yes. If you solve this, what am I getting it? So ये answer होगा M minus 4M will be minus 3M. Minus into minus will be plus. So this will be 3 3s are 9V/5. Are you getting it?
Sir, below we would take M1 plus M2 also, right?
Oh, very sorry. Into M1 plus M2, thank you. Because that's what I said, velocity तो बढ़ रही है. Velocity कम कहाँ से हो रही है? Velocity बढ़ रही है. Into M1 plus M2, what is M1 plus M2 we are getting it? M1 plus M2 will be equal to how much? M plus 4M.
5M.
यहाँ पे होगा M plus 4M हो जाएगा. और ये होगा 5M. So this is 9MV upon 5M into 5. MM will get cancelled. है ना? So what exactly my answer will be? 9V/25. Is this clear, students?
Yes, sir.
मुझे बताओ 9V/25 क्या होगा? What is 9V/25?
Final velocity of
This is final velocity of B after collision with A, and its direction in this. C was moving ahead. Students, C was moving ahead with how much? With how much? 2/5, yani 0.4 times V. Can you give me this answer in decimal? 9V/25, students, इसको solve कर सकते हो?
0.3.
Can you get a perfect decimals? दो digit में लिखा students.
0.36.
0.36 मिलेगा students. And students ये देखो, ये जब भी हिट होगा ना, B A को हिट होगा, A तो आगे की तरफ जाएगा. Students, अभी मुझे ये जरूरत नहीं है. Students, मुझे V2 फाइंड आउट करने की जरूरत ही नहीं है. क्यों जरूरत नहीं है? क्योंकि मुझे नंबर ऑफ कोलिशंस चाहिए ना. तो B पहले C को कोलाइड हुआ तो पहला कोलिशन हुआ, फिर इस तरफ आया, फिर B A को कोलाइड हुआ तो सेकंड कोलिशन हुआ, सेकंड कोलिशन के बाद में वापस B इस तरफ आ रहा है, तो जब ये इस तरफ आ रहा तो उसकी स्पीड 0.36 v है. बाय दैट टाइम c की स्पीड क्या है? 0.40 v. तो 0.36, can I say it's less than 0.40? So will B will be able to catch?
No.
B cannot approach C. Therefore, no further collision. No further collision. So how many collisions are there? Number of collisions will be simply equal to how much? 2.
2.
क्या ये clear हुआ students, all of you all?
Yes, sir.
So simply use your formulas for final velocities after collision. Can I erase this?
Yes,
No,
sir.
sir.
Yes sir, no sir, I could hear both of them. Should I erase or no?
No, sir. Wait.
Okay, fine. Yana, did you get it now?
Yes.
Sparsh, what about you? Gauri, what about you? Are you getting it?
Yes.
Sparsh, Sparsh, what
Yes,
about
sir.
you?
Yes, sir,
Why
got
you
it.
were absent? कल क्यों absent था?
सर प्रेजेंट था कल.
कल present था तू?
हाँ तो स्क्रीनशॉट भी लिया था
Okay,
आपके
fine.
नोट.
Oh, very sorry then. Then Shona, she was absent. Shona was absent. Yana's best friend was absent. Udit, you were absent, isn't it? Udit, are you there? अरे text कर रहे हैं सुबह सुबह. So the next question goes to Udit because Udit was present. He's saying it. Okay, Udit. ये विधि परमार का क्या है? Problem क्या है? विधि परमार is not there in the lecture. What is she doing up to? Vidhi Parmar, are you there in the lectures or not? Vidhi Parmar, if you now don't reply, I'm going to throw out all the lectures. Very good, Udit. Udit says, sir, I will try. You have any other lectures,
Sir, done.
students? Today?
What, sir?
Today you have some more lectures today
Yes, sir.
Yes, sir.
So one in the afternoon.
in the afternoon,
Yes, sir.
3:30.
Yes, sir.
Now, two more questions. These are slightly on the easier side. Let's see if you can crack it or not. So it's given to you that a block of mass m moving at a speed of v. So the first question speaks about a block of mass m moving with the speed of v, okay, collides with another block of mass 2m. Collides with mass 2m, okay, at rest. The lighter block comes to rest after collision. Lighter block comes to rest after collision, students. Find E. That's the first question, students, and it's an easy one. Second question, students. The coefficient of restitution, students. So the coefficient of restitution for a ball falling from rest, on a ground I need to find out, students, the coefficient of restitution for a ball falling from rest on ground from height h is. I repeat, students, the coefficient of restitution for a ball falling from rest on ground from height h is. Options, I'll give it to you, students. Options are.
Sir, are there two different questions?
Yes, two different questions. First and second. Option B, under root h dash by h. Option C, under root h minus h dash by h. Option D, under root h minus h dash upon h dash. So these are two questions. First question, I repeat again. A block of mass m moving with a velocity v collides with another block of mass 2m which is at rest. The lighter block comes to rest after collision. Find out the coefficient of restitution. The coefficient of restitution for a ball falling from a rest on a ground from height h is. There's one who knows both the questions, students, raise your hand, okay? Both the questions, not one. One who knows both these answers, raise your hand. No reply from Vidhi Parmar, so removed. Yes, anyone? Come on, Shona, are you there, Shona? Shona, are you there? Shona, reply. Oh, she's not there. She went.
Sir, I've done the first
I want both. Swani, you have done both?
Yes, sir.
Okay, Swani, answer.
First one is 0.5.
Second one,
Second one is option A.
option A. Students, is she right or wrong? Is the first answer and second answer both correct? Anybody who wants to disagree with her? Students?
Sir, what is H dash in the options?
Does the body strikes the ground? Does the body strikes the ground? Ayana? Ayana, are you there?
Yes.
And the body is falling from a height? Ayana, the body is falling from height what?
H.
So after striking the ground, won't it rebound?
Yes.
Will it try to maintain the same height?
No.
Okay. I deliberately didn't give you this. Now, students, you can put down this. Suhani, now think further. Suhani, your second answer was incorrect. Your first answer was correct.
Okay.
Now, who can give me the second answer correct? Suhani, you still want to answer? Your hand is raised.
Second one, I have approached something, but I don't know. I think the answer could be B.
Okay, that's a correct answer, students. Students, over here, the answer is B, and over here, students, E is equal to half, and that is equal to 0.5. Okay, please pay attention, students. The first one, it's very easy to get it. So now you're not replying. If you don't reply, I'm going to throw out all the lectures. Since the first problem, if you see it over here, a block of mass m moving with a velocity v collides with a block of mass 2m initially at rest using law of conservation of momentum. Okay, the lighter block comes to rest. Okay, and the heavier block now moves with the velocity v dash. So can you find out v dash in this case? Yes, it's m into v is equal to 2m into v dash, students. So what exactly it will be? Your v dash will be equal to how much? V by 2. Agreed, students? That's the final velocity of the bodies after collision we consider. Now, if I want to go for your coefficient of restitution in this, can you give me the formula for coefficient of restitution, students? It's a ratio of what, students? Anybody can tell me the
V1
difference?
minus V1 upon U1 minus U2.
Yes, that means it's a relative velocity. Since it's a relative velocity of the two bodies after collision to the relative velocities between same two bodies approaching before collision. Again, this is approaching and this is receding after collision. So after collision, ये क्या होगा? V by 2. इसका क्या होगा? It's at rest. We consider in this case. I'm getting it. The body is at rest. So now, if in case if I happen to get a minus 0, यहाँ पे क्या होगा? इसका velocity v है और ये 0 है. So now can I say what's my answer will be? V by 2V, cancellation of V is what's my answer? Half, 0.5. Coefficient of restitution has no unit, it's a pure ratio. Students, I made it very clear, the value of E lies between, students, it lies between 0 and 1. For perfectly elastic collision, E will be equal to 1. For perfectly inelastic, E will be equal to 0. Inelastic collisions, I need to speak, which I'm going to speak after this question. So students, E is equal to 1 and E is equal to 0. This is perfectly elastic collisions where kinetic energy is conserved. Students, दोनों case में linear momentum is conserved. लेकिन when E is equal to 1, perfectly elastic kinetic energy is also conserved. यहाँ पे change in kinetic energy will be equal to 0. यहाँ पे change in kinetic energy is not equal to 0. There is loss in kinetic energy. Okay. Second case. Second case, Ms. Shivani, can you tell me now how you're going to go about with this?
So in the second case, first we'll find out the final velocity when it reaches the ground, where the formula of v square is equal to u square plus 2as. Then after colliding, it will bounce back. So the final velocity will be 0. And then with the same formula, we'll find the initial velocity, which will be under root 2gh dash with negative sign. And then after that, we'll find the coefficient of restitution by the relative velocity after collision upon relative velocity before collision. So we get under root h dash by h.
Absolutely correct, students. Since यहाँ पे जब तुम solve करोगे तो तुम्हें कौन सा equation use करना है? Students, go for equation of a free fall. Now, when you go for the equation of a free fall, students, when a body is made to fall vertically downward, students, what is the velocity with which, students, यहाँ पे तुम्हारे which are the two objects? Can you tell me which are the two objects? Where is a collision taking place? तो तुम्हारा first object होगा, students, ये object है, ये body, जो नीचे की तरफ गिर रहा है with initial velocity 0 and falling from a certain height. Students, your second object is the ground of a huge mass, which is always at rest. Students, ये तुम्हारा second object, collision इसके साथ में हो रहा है. So when this body is made to fall with respect to this, can you tell me the formula for the velocity of free fall, students? So what's the formula, sir? I can use the formula v square is equal to u square plus 2as, that means 2gh. Initial velocity in both the cases will be 0. Therefore, what is the velocity of body to strike the ground? Under 2gh, that's my equation number 1. है ना? यानी अगर मैं देखूं, what exactly initial velocity of this will be given to you is this. What is the initial velocity of the ground is 0. Coefficient of restitution का formula क्या है? Students, ध्यान से सुनना. What exactly coefficient of restitution का formula? Relative change in velocity of the two bodies after collision to the relative velocities of the same two bodies before collision. तो अगर मैं यहाँ पे substitute करूं तो u1 क्या होगा? सर, u1 is a body falling down, तो ये मेरा u1 होगा, students. तो u1 क्या है? I'll put it as under 2gh. What is u2? u2 is for the ground. The ground is at rest, minus 0 ही होगा. क्या ये clear हुआ, students?
No, sir.
After
ये part नहीं
striking
समझा.
it, yes, pardon?
So I didn't understand this part, how this u1 and u2 is root 2gh and 0 respectively.
Didn't get it still.
No, sir.
और अदिति, मुझे बताओ, ये
I
जो
don't
बॉल बॉल हाउ कैन यू से, आई डोंट नो. एक बॉल है और एक ग्राउंड है. बॉल का मास m है, समझ में आ रहा है?
हाँ
ना?
सर.
ग्राउंड क्या
हाँ
है?
सर.
ग्राउंड नीचे है, ग्राउंड रेस्ट पे.
रेस्ट पर है.
ओके, अभी ये बॉल को अगर मैं ग्राउंड के साथ में स्ट्राइक करूंगा तो विद व्हाट वेलोसिटी द बॉल इज स्ट्राइकिंग द ग्राउंड? अंडर 2g.
हाँ सर, understood. That is at 0. Yes sir, understood.
Am I getting it? So what exactly?
Yes, sir.
u1 is the initial velocity of the ball, u2 is the initial velocity of ground, which is at rest. Ground the rest पे. After
Yes,
collision, what is happening? After collision, what is happening?
so it is gonna rebound.
It will rebound in this case. Are you getting it?
Yes sir.
So now what exactly in this case? The final velocity of the body we consider. After hitting, what happens? It will change its direction in that case. So v2 will be in the upper direction, but still the ground will be at rest. So उसका आंसर क्या होगा? What is the formula for v2 in that case? If I happen to consider, what exactly will be? उसका भी आंसर क्या होगा? Under root 2GH dash. आया ना? Students, at maximum height, what exactly is final velocity? Will be 0. Using the same equation, students, ये 0 हो जाएगा. ये तुम्हें चाहिए. ये तुम्हें 2GH होगा माइनस, वो यहाँ पे चला जाएगा. So what exactly V is equal to under 2GH dash. तो वो तुम्हारा क्या होगा? 2GH dash न्यूमरेटर में आएगा. And this is 0 itself only. ये तो आएगा नहीं तुम्हारा factor. What is the answer? So under 2GH dash upon 2G, 2G will get cancelled. What's the answer? H dash upon H. Is this clear to all of you all?
Yes, sir.
Students, now please pay attention in this case. When I speak about it over here, students, we try to speak about the final velocity of the bodies after collision. Students, we consider. So when it collides, the velocity with which it's projected upward, students, वो final velocity यानी ये v नहीं होगा, u ही होगा. यहाँ से भी hit होने के बाद में जो velocity इस body को मिलेगा वो u है. ऊपर जाने के बाद में उसकी v 0 हो गया ना. और ये तो negative में आएगा. यहाँ पे लोगे तो positive आ जाएगा. That's why it's under root h dash upon h we consider. So students, this becomes your point of synopsis. अभी ये ध्यान में रखना, point of synopsis. And what is the point of synopsis? The coefficient of restitution for a body falling from rest on the ground at a height h, and if it rebounds to a height h dash, coefficient of restitution is under root h dash by h. Please make this as a point to be noted. Don't forget this when you're solving simple questions based on this. Can I erase this entirely, students?
Yes, sir.
Okay. Okay, so now we go for this. Now this becomes your last part of the topic, students. Okay, speaking about perfectly inelastic and a few questions onto oblique, two-dimensional oblique collision, students. Now, when you speak about, students, what exactly perfectly inelastic? Students, perfectly inelastic collisions are those kind of collisions, students, are those collisions in which both the bodies couple together, both objects, I can say coupled, any stick to each other. Students, both the bodies coupled together, yeah, stick to each other after collision. After collision, and they move with the same speed. And move with same speed. Students, I repeat, perfectly inelastic collision. The word perfectly inelastic collisions are those kind of collisions in which both the objects, they get coupled or stick to each other after collision and move at same speed. But do the two bodies move initially? Yes. Think as if I have a body M1 and it's going with velocity U1. Another body is M2. This is U2. Students, a straight line joining them, what exactly we consider this as? Of course, this is called as a line of impact. ये है line of impact या line of collision या line of impact. हमेशा हम impact के बारे में बात करते हैं, students. अगर किसी ने पूछा coefficient of restitution कहाँ पे act हो रहा है? Students, coefficient of restitution E. ये भी ध्यान में रखना. E always plays a role along line of impact या line of collision. So जहाँ पे line of collisions के बारे में वहाँ पे ही तुम coefficient of restriction के बारे में clear करोगे. यानी you need to go for U1 and U2 are the two bodies in the same direction we consider. Let us say U1 का speed is greater than U2 तो क्या होगा? They will be colliding with each other. But after collision, students, after collision of two bodies will now stick with each other. And now they move with the same velocity v. Then in that case, what kind of collisions are these are called as? Perfectly elastic collision. Since in perfectly elastic collision, their change in kinetic energy is not equal to 0. That means there is loss in kinetic energy. Is linear momentum conserved? Yes, linear momentum is conserved. You will find out conservation. But is kinetic energy conserved? No, kinetic energy is not conserved at all. Now, if I happen to go for the formula, what is the linear momentum? It's m1u1 plus m2u2 upward with vector. यहाँ पे क्या होगा m1 plus m2 into b.
So,
Agreed?
Perfectly elastic.
perfectly elastic or perfectly inelastic.
Perfectly inelastic. Perfectly inelastic. Very sorry. Perfect. I'm giving the heading. It's already written. Perfectly inelastic. Since it's perfectly inelastic, there is no change in kinetic energy. Kinetic energy is not equal to 0. There is loss. Since there is loss in kinetic energy. Is that clear?
Yes.
Yes, sir.
Since it's inelastic collisions. Once again, I speak about it. Inelastic collisions are those in which both the objects are coupled together and both can set to move at same velocity. There is loss in kinetic energy. Linear momentum is considered. Now, if I want to go for the kinetic energy, students, what exactly kinetic energy I'll consider will be? It's half m1 u1 square plus half m2 u2 square. Over here, यहाँ पे क्या होगा kinetic energy? m1 plus m2 v square. The total mass of the two bodies will be summation of the two masses into square of the velocity we consider. So students, whenever you try to go for problems based on to perfectly inelastic collision students or inelastic collision students, you need to go for this. Whenever you go for perfectly inelastic collision students, you can consider your coefficient of restitution to be equal to 0. Students, E is always 0 for this. Now see, please pay attention. What is E? What is the formula for E? You'll say, so the relative velocity of the two bodies after collision to the relative velocity of the same two bodies before collision. Hayana? Agreed? Is this formula clear?
Yes, sir.
अभी E क्या है for perfectly inelastic collisions? Inelastic collision के लिए मैंने E को perfectly word use कर रहा हूँ मैं. Perfectly होगा तो E की वैल्यू क्या होगा? 0 is equal to V2 minus V1 upon U1 minus U2. Therefore, can I say V2 minus V1 is equal to 0? Therefore, can I say V2 is equal to V1? So, will the two bodies will move at different velocities or will they have same velocity? Same velocity. क्या ये clear
Sir,
हुआ?
I want to confirm one thing. I think I've written wrong in the formula of restitution. Sir, it would be V2 minus V1 upon U1 plus U2 or U1 minus U2.
No idea. U1 minus U2 relative change. Students, ये relative velocity है. Students, again I repeat, what is the definition of coefficient of restriction I gave you? Definition of coefficient of restriction is defined as a ratio of relative velocities of two bodies receding after collision. Students, the word receding is also there, but it may or may not be given in your books. But we can say it's a ratio of relative velocities of the two bodies after collision to the relative velocities of the same two bodies before collision. And when I go for relative velocity means what? It's a velocity of one with respect to another. So ye kya hoga? This is actually velocity of two with respect to one. Ye kya hai? Velocity of one with respect to two. In the first case क्या था? देखो ना u1 is greater than u2, तो ये difference आया. Second case में शायद v2 का speed बढ़ेगा. और ये vectors में भी तुम लिख सकते हो students. Coefficient of distribution. The value of E can be considered between any kind of practical examples में तुम लोगे ना students, whatever examples you take it, E का value will be always between 0 and 1. It cannot be equal to 0, it cannot be equal to 1 unless and until theoretically told to you word perfectly. स्टूडेंट्स कभी भी कोलिजन परफेक्ट नहीं होता, तो जो भी तुम प्रैक्टिकल एप्लीकेशंस में लोगे ना स्टूडेंट्स, तो ई की वैल्यू हमेशा तुम्हें, ई की वैल्यू इज ऑलवेज बिटवीन 0 and 1। हाँ, लेकिन अगर तुम थियोरेटिकली तुम प्रॉब्लम सॉल्व करते हो और उसमें वर्ड परफेक्टली यूज किया है, तो अगर परफेक्टली यूज किया है तो E कैन बी इक्वल टू 1 फॉर इलास्टिक and E is equal to 0 for inelastic. Is this clear about me now?
Yes, sir.
Can I erase the students now? Can I erase it, students?
Yes, sir.
Aisha Hafiz. Aisha, why so late, Aisha? Aisha, I want to ask you, why so late in the lectures? Aisha, if you don't reply again, I have to put you in the waiting room. Kindly reply why you're so late. And Shona, are you there still in the lectures or not? Because I threw you out, I kept you in the waiting room, but still I took you in. Are you there? Yana, your friend, she's not replying at all. Huh? She has kept the mic on. She's listening. She's not speaking. And then she'll say, my mic is not proper. We can hear the background sound. She shut it. तुरंत shut कर दिया mic को. Now, students will go for concept of public collation. Okay, students. Now, this I'll consider to be as a kind of an elastic collision. Okay, students, but in two dimensions, in 2D. Okay, in a given plane we consider, and therefore it can be considered as oblique collision. Since अभी भी oblique collision का बात करोगे तो वो two-dimensional collision you can consider, students. Of course, the bodies are going to change the path, in this case after collision. Nothing as if, students, you have, if the colliding bodies do not move along the same straight line. Students, if in case if one asks you what exactly oblique collisions? Colliding bodies do not move along same straight line path. Do not move along same straight line path. Students, what is this called as? Anybody can tell me what is the same, what is straight line path is called?
Line of collision.
Very good. Line of collision or line of impact. Okay. So अगर ये दोनों bodies ये line पे नहीं move होते हुए collide के अपना direction change करता है, then the collisions is said to be oblique collision. Okay. Now take a simple example, students. Think as if there is a cue ball. Students, hope you know what exactly a cue ball is. Okay. A snooker ball. Okay. ये बॉल है जिसका मास मैंने m1 दिया स्टूडेंट्स. ये उसका सेंटर ऑफ मास. Agreed? I'll consider. ये तुम्हारा एक horizontal surface है स्टूडेंट्स. I'll consider in this manner. Okay. ये पूरा एक, it's an entire plane students. This is an entire plane. I'm trying to go for it. पूरा डायग्राम एक प्लेन में दिया है. Now, if I happen to consider students, there is another ball at a certain distance. Let me take that as mass m2. Okay. इसको मैं नाम देता हूँ टारगेट बॉल. तो ये है मेरा क्यू बॉल और स्ट्राइकर. एग्रीड. और ये मैं बोल रहा हूँ इसको m2, जिसको मैंने दे दिया है टारगेट बॉल, जिसको हमें टारगेट करना है स्टूडेंट्स. Now, if I say that your m1 is moving with a speed u1, students, m1 is moving with a speed u1. And if I say m2 is initially at rest. Okay, but will there be head-on collision, students, between the two?
No.
Of course, the collisions will be elastic, but will it be head-on? It will be a kind of an oblique collision, students. Oblique collision क्यों? क्योंकि अगर तुम देखोगे, what exactly is a straight line of impact? Students, ये इसका center of mass है. Again, the body is placed over here. So the line joining this with the center of mass. Because see, when I say whenever a body collides, students, whenever a body collides, we say that the algebraic sum of net force is acting at the center of mass. So ये तुम्हारा actual होगा line of impact, students. If I look over here, this becomes your line of impact. Yani coefficient of restitution will always play a role along this line of impact. तो इसको मैं dotted line आगे कर लेता हूँ. यानी actually अगर ये head-on collision होता, students, head-on collision होता along a line, तभी भी जा सकते students. जब भी head-on collision होता था ना elastic, तो हम लोग क्या करते थे, दोनों bodies को एक level surface पे रखते थे और फिर उनके center of mass के बीच में exactly dotted line आता था. तो वो हो जाता तुम्हारा line of impact. लेकिन यहाँ पे देखो, ये बॉडी का बेस है और ये बॉडी का सेंटर ऑफ मास है. Are you getting it, students? लेकिन तुम्हारा जो मोशन होगा will precisely go for this, because this is my target ball. I need to look at this. What exactly is happening onto this? We are going to speak about that and not for this. But after collision, will this body also will change its direction? Yes. So ये तुम्हारा होगा line of impact या line of collision we consider. So this is what is called as line of collision. Now, when the two bodies hit each other, students, what's going to happen? After colliding, maybe one body will try to move in this direction, students. The other body might go in other direction, students. Maybe same angle or maybe different angle. Let us say that the body M1 forms an angle θ1 with a line of collision, students. And now the body is moving. Body M1 is moving with the final velocity v1 in this direction, students. Agreed? Likewise, m2, यानी ये मेरा क्यू बॉल होगा और ये मेरा स्ट्राइक बॉल है. Sorry, target ball. This is m2, students, and it's moving with velocity v2. Let us say it forms an angle of θ2 with the line of impact. Now, in this case of oblique collision, students, is momentum and energy is conserved? Yes, because I use the word elastic collision. Since ये है elastic collisions, लेकिन ये oblique है, यानी यहाँ पे तुम्हारा energy, kinetic energy can be conserved. Kinetic energy conserved का मतलब initial kinetic energy of the two bodies before collision should be exactly equal to the kinetic energy after collision. Will there be momentum conserved? Why not? Now, first of all, let us find out how to get the momentum of the two bodies. Students, momentum of the two bodies is always along a straight line, because we are trying to speak about, students listen carefully, law of conservation of linear momentum, students. That means the momentum of the two bodies is conserved always along the line of collision. Students, law of conservation of linear momentum is always on the line. यानी तुम्हें इसी पार्ट के ऊपर उनका कंजर्वेशन देखना है. तो अगर तुम्हें ये वेलोसिटी v1 है, मास m1 है, तो तुम क्या करोगे सर? इसको रिजॉल्व करना पड़ेगा. मोमेंटम का मतलब क्या? प्रोडक्ट ऑफ मास इनटू वेलोसिटी. सो नाउ इफ आई हैपन टू गो फॉर इट, इसको रिजॉल्व करो v1 को. अगर मैंने v1 को रिजॉल्व किया स्टूडेंट्स, तो मेरा एक वेक्टर इस तरफ आएगा, दूसरा परपेंडिकुलर चला जाएगा. एग्रीड? नाउ इफ आई हैपन टू गो फॉर द मोमेंटम इन दिस डायरेक्शन, तो क्या लिखूंगा मैं? सो दिस इज m1 v1 cos थीटा 1. ये क्या है? m1 v1 sin theta 1. क्या ये क्लियर हुआ स्टूडेंट्स? Is this much clear to all of you all?
Yes, sir.
Linear momentum P is resolved into two components, horizontal and vertical. यहाँ पे भी देखो, अगर मैंने बोला ये m2 v2 is a momentum in this direction for the ball, which one? Target ball, forming an angle theta 2 with the line of impact. Can I resolve this? Yes. ये क्या होगा? ये होगा m2 v2 cos theta 2. यहाँ पे होगा m2 v2 sin theta 2. What is law of conservation of linear momentum? Students, law of conservation of linear momentum towards that the total momentum before collision. Students, what is the total momentum before collision? What is the total momentum before collision? Sir, it's m1 u1 plus m2 u2 will be equal to what? Total momentum after collision. So can I say this will be equal to m1 v1 cos theta 1 plus m2 v2 cos theta 2, and that becomes your formula for law of conservation of linear momentum for what kind of collisions? Oblique, but elastic in nature. Students, यहाँ पे देखो, यहाँ पे तुम्हारा ये रेस्ट पे था ना, तो u2 तुम 0 लिख सकते हो. लेकिन अगर बाई चांस सपोज मैंने बोला कि ये भी बॉल मोशन में है, you can, students, you can make a ball to move with motion with u2, but u1 is greater than u2, तो तभी भी कोलाइड होगा. तो स्टूडेंट्स, प्रॉब्लम्स के टाइम पे u2 बताना जरूर. हाँ, और रेस्ट होगा तो 0 डाल दो, अगर नहीं होगा तो उसका स्पीड डाल दो. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
Yes.
Everyone, please, I'm not explaining just 3 or 4 students. Aisha, Hafizi, still you're not replying. If you don't reply, I'm going to throw you out of the lectures. Aisha, Hafizi, you're not replying again. Enough of yours. You'll come to your comfort. जब भी तुम्हें मूड होता है तभी तुम आते हो. जब मूड नहीं होता और फिर रीजन दोगे कि तुम्हारा वाईफाई का इश्यूज है. Even Shona also didn't reply at all. Yana, did you speak to your friend?
Yes, sir.
Okay. Saud, are you there in the lectures?
Yes, sir, I am there.
Okay, good boy.
Sir,
Yes.
what have you written there? Colliding
Where?
bodies do not move.
कहाँ पे?
Sir, उसके आगे क्या लिखा है? Colliding bodies do not move.
Do not move along same straight line path. After collision, they do not move. They move diagonally. Students, is the screen proper? Are the writings proper? Can you see it properly?
Yes, sir.
Yes, sir.
Okay, fine. अभी ये तुम्हारा law of conservation है. What about kinetic energy? Is a kinetic energy, और ये जो law of conservation of momentum है, कौन सा? ध्यान से सुनना. Students, ये जो law of conservation of linear momentum है, ये मैंने कहाँ पे लिया है? It's along which axis? Sir, along x-axis लिया है मैंने. Can I say the momentum is conserved along y-axis also? Why not? Yes, Suhani, you want to ask something, Suhani?
Just that only that you said no about y-axis.
Oh,
That only.
fine, fine. Along y-axis also we can consider. Why not? They are in opposite direction. Students, यानी अगर तुम देखोगे ना along y-axis, please pay attention. तो मैं क्या लिखूंगा? ध्यान से सुनो. Students, अभी मैं इसको यहाँ पे बता रहा हूँ. m1 v1 sin theta 1. अगर मैं उसको डायरेक्शन में देख रहा हूँ स्टूडेंट्स, तो ये क्या होगा, नेगेटिव ऑपोजिट डायरेक्शन में होगा, तो ये क्या होगा, -m2 v2 sin θ2। ये नेगेटिव साइन क्या बताता है, सिर्फ डायरेक्शन, दे आर इक्वल इन मैग्नीट्यूड, ऑपोजिट इन डायरेक्शन। फ्रेंड्स इसको मैं यहाँ पे ले लूंगा तो समेशन क्या होगा, so the momentum, the final momentum of the first body, I cap, we consider, I getting it plus I cap, and plus minus I cap we consider. So the total momentum we consider is conserved along y-axis also. क्या ये clear हुआ students?
So initially along y-axis it was 0, and
Yeah.
after impact it is m1 v1 sin θ1
Of course.
and minus m2 v2 sin θ2.
Yes. तो यहाँ पे अगर तुम लोग तो summation will be equal to 0. यानी students, can you go for equal in magnitude? Why not? So ratio of sin θ1 upon sin θ2 can be written in terms of p2 by p1. Students वैसे वाले भी, यानी तुम्हें कुछ टाइम पे प्रॉब्लम्स वैसे भी होंगे, तो वहां से तुम्हें कुछ हिंट मिल सकता है in order to move further with your question also. See vertical होगा, अगर ये equal होगा तो can I cancel out each other also? Why not? The equal in magnitude opposite. तो जब भी हम रोल प्ले करेंगे तो you're not going to go for this part of it, लेकिन वहां से तुम हिंट उठा सकते हो। लेकिन ये दोनों देखो equal in magnitude हो गया, opposite है, तो can I cancel them out? Yes, they rule out. Therefore, we do not consider along y-axis. We simply consider along x-axis. Now let us go for law of conservation of energy. Which energy? Mechanical energy, students. Can anybody give me the formula for law of conservation of mechanical energy over here, students? को बता सकता है? Because since the collisions are elastic, even energy is also conserved. So what exactly? Kinetic energy of the
Along
first
the
body.
x-axis.
Will be considering only along the x-axis, my dear. I'll be considering only along the x-axis. I will not consider along the y-axis at all. Half m1, friends, half m1. Sorry, I will not consider along x, not even along y. Okay, so Swani, wait a minute. Swani, answer. Bolo, tum bolo, answer. What is law of conservation of mechanical?
Half m1 u1 square plus half m2 u2 square.
Okay, ये initial हुआ. Final क्या लोगे तुम? Will you take the components?
No, sir, the speed.
यानी half m1 v1 square plus half m2, because it's a scalar quantity, it has no direction. Since law of mechanical energy, energy is simply a scalar. After collision, students, look at the cue ball. The cue ball is going in this direction with a velocity v1, that is with speed v1. So what is the energy associated during the motion in this direction will be half m1 v1 square. तभी तुम्हारे कंपोनेंट्स आएंगे, यानी तुम x भी नहीं लोगे, y भी नहीं लोगे, वो होगा ही नहीं पॉसिबल, बिकॉज इट्स स्केलर क्वांटिटी। और इस तरफ क्या होगा, हाफ m2 v2 स्क्वायर। क्या ये पार्ट क्लियर हुआ सबको?
Yes.
So is it clear?
Yes, sir.
Can I erase it now?
No, sir. Wait for 2 minutes.
So 1 minute.
पार्टी तो ऐसे बोलती है एकदम ये ना के जैसे।
So in this inelastic oblique collision is possible.
Pardon? No, my dear. How is it possible? The two bodies will be in contact with each other. How can it go? Oblique collision in the sense that means after collision, the two bodies will have the target and the striker. Both will move in different directions. Can I erase now, students?
Yes, sir, you can.
Right. Okay, students. Now, suppose if I give you a simple example onto this, students, suppose if I say there is a bomb, okay, of mass capital M, and it explodes. It explodes and it forms into 3 fragments. Okay. Now, if I say one moves at an angle of θ1 with the horizontal, other moves at an angle of θ2 with the horizontal. Can you estimate where exactly the third particle should go? ये capital
Opposite to
M
the
है.
resultant.
Yes. यानी यहाँ पे एक मास होगा m1, दूसरा एक मास होगा m2. यानी students, am I trying? Can you say that means it's actually the vector relation we are trying to go for it? हाँ, ये opposite direction में होगा. क्योंकि अगर इसका तुम लोग ये दोनों का वेक्टर्स का रिजल्टेंट किधर जा रहा है? शिफ्ट दिस वेक्टर पैरेलल टू इट्स. तो देखो, टेल है, रिजल्टेंट इस डायरेक्शन में जाना चाहिए. तो दिस इज गोइंग इन द डायरेक्शन ऑपोजिट. Why is it so? क्योंकि ध्यान से सुनना, इन दोनों का जो रिजल्टेंट आंसर होगा ना, वो उससे ऑपोजिट डायरेक्शन में आना चाहिए. इक्वल इन मैग्नेट ऑपोजिट डायरेक्शन. Therefore momentum is conserved. यानी अगर तुम मोमेंटम के बारे में बात करोगे स्टूडेंट्स, so it's breaking into 3 fragments. Let us say that this is going with velocity v1, this is going with velocity v2, this is going with velocity v3. Agreed. हमारा line of impact यही होगा स्टूडेंट्स, line of impact यही होगा. लेकिन what is the total momentum of the entire body before तुम क्या बोलोगे? So the entire mass was capital M. Was it in motion? No sir, it was not in motion, so the total will be 0. यह है initial momentum. क्या ये clear हुआ students?
Yes.
Of the entire bomb. Please pay attention. Now what happened to Janani? Janani का reason ये होगा कि मैं जा रही हूँ. देखा Janani का problem है. Last time also, yesterday also she gave the same piece. Okay, so the initial momentum of the capital M is equal to 0. What about final momentum, students? What is the final momentum of the body? तुम बोले sir, can I resolve this? हाँ sir, देखो ना, ये होगा क्या? m1 v1 cos θ1. Agreed. और ये क्या होगा? m1 v1 sin θ1. यहाँ पे m2 v2 cos θ2. और ये होगा m2 v2 sin θ2. ये दोनों equal in magnitude opposite direction. ये तो rule out हो जाएंगे along y axis. So what's the momentum after? तो बोलेंगे सर ये होगा m1 v1 cos θ1. I getting it? That is along x axis I can consider, plus m2 v2 cos θ2. What about this? Can I say this is in the direction of m3 v3, which is in the direction opposite? हाँ या ना?
Yes, sir.
यानी ये नेगेटिव में आएगा कि नहीं आएगा? हाँ स्टूडेंट्स?
Yes, sir.
अगर तुम इसको लोगे तो यहाँ पे पॉजिटिव होगा. So can I say the momentum is conserved? Students, ये दोनों का आंसर इससे मैच होगा when you take it on the. That's why I put this into vectors notation. क्योंकि ये तो 0 है. So total momentum is conserved after explosion, students. क्या ये clear हुआ students when questions of these kind comes?
Yes.
Students, is it clear?
Yes, sir.
Now if I say what about the
Yes.
kinetic energy? Kinetic energy is also conserved. तो पहले केस में क्या होगा? तुम्हारा kinetic energy क्या होगा? अगर इसका kinetic energy अगर तुम लोगे तो exactly kinetic energy इसका तो 0 होगा. Are you getting it? For the entire system will be 0. What's the kinetic energy for this one? So same thing, it's half m1 v1 square. Agreed. Plus what exactly consider will be? Plus half m2 v2 square. और ये क्या है? Plus half m3 v3 square. What about the total kinetic energy before and the total kinetic energy after? The total kinetic energy after collision will be half m1 v1 square plus half m2 v2 square plus half m3 v3 square. And that is what we consider. अगर तुम यहाँ पे देखो तो the total kinetic energy is equal to 0. That means change क्या होगा? This minus this will be also equal to 0. क्या ये clear हुआ, students?
So here we will not take
Fine.
that half
Pardon?
m3 v3 square as negative.
No, my dear, it's energy. It's energy. It's energy. Again, I'm telling you, kinetic energy is a scalar quantity. You're not going to go for
So
vectors at all. Never to use vector notations in mechanical energy, students. You have learned work, power, energy. Work, power, energy, all three are scalar quantity, students. Power is a scalar, is a dot product of F dot V. Work is F dot S, and work and energy are correlated. Agreed?
okay.
अगर
Final
मैंने
energy,
हाँ बोलो.
final energy, how it will come 0?
No, if I happen to get there's a change. If I take it this on the other side, in that case, means the summation of total energy is what? Remains constant throughout. This energy part of it. Initial is not there at all, we consider, because the initial is total 0. If I happen to go for the final in this case, and agar main summation iska le raha, that will be equal to negative of some. If I take these two, will be negative of this. That means they're trying to balance the total energy of the system. The total energy of the system after collision remains constant. Is this clear?
Yes.
Now, if
Yes.
I happen to go for a single object, students, अगर मैंने एक single bomb लिया है और इसको मैंने एक fragment ऊपर गया, students, एक fragment ऊपर गया, अगर मैंने बोला चलो m/4 ऊपर की तरफ गया इसमें से, तो students दूसरा fragment कहाँ की तरफ जाएगा? बता सकते हो? ये जब भी explode होगा, एक अगर ऊपर की तरफ गया तो दूसरा fragment किस तरफ जाएगा? नीचे की तरफ ही जाएगा. ये हमेशा ध्यान रखना. अगर सपोज मैंने ये m/4 दिया तो यहाँ पे कितना मास होगा? ये ध्यान में रखना, स्टूडेंट्स. When it comes to questions, they will not give you, please, they will not give you all the things that you should understand. अगर सपोज मैंने ये कैपिटल M दिया है और मैंने यहाँ पे स्मॉल m दिया है, तो यहाँ पे क्या होगा? कैपिटल M माइनस
m.
क्या ये क्लियर हुआ?
Yes.
Yes, sir.
Can I erase this? Can I erase this, students?
Yes.
Okay. Now kindly solve the question, students. Okay. Students, given to you, there is a cue ball. Okay. And there is a striker ball. Sorry, the target ball. This is the target ball. Since cue ball is always called as a striker. And this is the target. Okay. Now listen carefully, students. A cue ball is stuck to a target ball, which is at rest. This is at rest. Both of them are of equal masses. So if I take this as m1 and if I take this as m2, so m1 is equal to m2. Okay. The target ball is to be put. Now I want the target ball. Suppose if I happen to go for this is a snooker table, think as if this is a snooker table. Okay, snooker table यानी एक plane आ गया. I getting it? मैंने hit ऐसा किया है कि मुझे जो target ball है, मुझे ये pocket में चाहिए. ये pocket है, students. So I'm hitting it over here. So now listen carefully. The target ball is to be put into a corner pocket. I want the target ball to be put into corner pocket, okay, of a snooker table. Is that clear? So I want to put the target ball is put into a corner pocket, which is at an angle of theta to 37 degrees. This is at an angle of theta to 37 degrees. मुझे बताओ theta to 37 degrees किसके हिसाब से होगा?
Line of action.
Yes, यार ये तुम्हारा line of collision, line of impact. यानी तुम्हारा line of impact ये जा रहा है students. It's forming an angle of theta 2 and that is equal to 37 degrees students. Okay. Assume collision is elastic. Collision is elastic. That means momentum is conserved. That is what obvious. In either cases, kinetic energy is also conserved, students. Collision is elastic, and the friction and the rolling motion of the body. The balls are not rolling. They are rotating. Are you getting it? Not rolling. I'll consider more precisely rotational. Students, friction and rotational motion. Students, frictional and rotational motion is neglected. That means there is no friction we consider. As if there is no friction, there is no opposing forces. The surface is very smooth for them to move, and the balls are not rotating about its axis. So we are neglecting friction and rotational motion, students, or it is ignored. My question to you, students, obtain angle theta 1. Obtain angle theta 1 for the cue ball with line of collision. Obtain angle theta 1 of cue ball with line of collision. Is the question clear to all of you all?
Yes.
I repeat, students. Question kya hai, students, everyone? A cue ball which is of mass m1 and other is a target ball of mass m2. Both of them are of same masses. Okay. The target ball is at rest and the cue ball is set into motion. The cue ball hits the target ball such that the target ball should enter into the corner pocket. Okay, at an angle of theta to 37 degrees. So, but of course, I'm taking it with the line of collision we consider. Considering the collisions to be elastic in this case, eliminating friction and the rotation of the two objects, the two balls, find out theta 1, that is the angle of the cue ball, the angle formed by the cue ball with the line of collision. Hope the question is clear to all of you. Now, the strength was 24, 2 students went out. See, that girl, she was there, na? What's that Muslim girl, she was, I don't know what's her name, I forgot. I kept her into the waiting room, thinking कि मैं waiting room के बाद में वापस उसको मैं ले लूं. But just now when I just drew the diagram and come before this only, I just put her into the waiting room. और ये diagram करना, I was just checking the waiting room. She's not there. She left. This is a problem with the students. Alicia, what's her name?
Aisha, sir.
Okay. Yes, students, can you give me an answer for this? Now a student will think, sir, आपने theta 1 पूछा, आपने सिर्फ एक ही दिया है, 37 और दोनों का मास सेम दिया है ना students? तो ध्यान से सुनना. Let us say that this particular object is moving with you, है ना? ये जा रहा है with v1, है ना? Mass is m. ये इस तरफ जाएगा, दूसरा जो m1 होगा वो, सॉरी, ये v2 है. ये है mass of the cue ball with v1. क्या ये clear हुआ students? This is a cue ball and this is a target ball. टारगेट बॉल जा रहा है पॉकेट के अंदर, क्यू बॉल हिट होगा कॉर्नर को, पॉकेट यहाँ पे, पॉकेट में नहीं आ रहा है. I want to find out this angle θ1. Students, what did I tell you? Can I shift this vector parallel to itself? Everybody listen carefully. Can I shift this vector parallel to itself? अगर मैं यहाँ तक लेता हूँ स्टूडेंट्स, ये वेक्टर को मैंने शिफ्ट कर दिया पैरेलल, तो ये होगा, इट्स गोइंग इनसाइड. टेल हेड, यानी ये तुम्हारा V2 है, ये तुम्हारा V1 में ले रहा हूँ. टेल हेड रिजल्टेंट ये है, तो कहने से दिस बिकम्स नथिंग बट माय U. हाँ, can I consider my parallelogram law of vector addition? Resultant vector is equal to V1 square plus V2 square plus 2 V1 V2 cos of θ1 plus θ2. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
Please students, is it clear? Of course, why not? I made it very clear students. Initially also I told you the vector sum. अगर मैंने bomb का explosion मैंने किया था, तो मैंने क्या किया था students? The final velocity, students, I want the momentum should be conserved. I want the momentum should be conserved. At the same time, I want the kinetic energy to be conserved. The masses are same in that case. Yana, is it clear, Yana? Yana, is it clear? Okay. Okay. Now let us prove this. चलो, तुम ये मैंने डायरेक्ट दे दिया students. चलो, now let us prove. Okay. Now listen, students. Are the two masses same? Yes. Can I go for law of conservation of linear momentum? Everybody listen carefully. Yeah? Please pay attention. अगर मैं law of conservation of linear momentum लेता हूँ, तो let us say m1. Okay. Let us take this as velocities u m1 u1 plus m2 u2, यानी तो 0 होगा. Agreed? m1 v1 plus m2 v2, ये m ही है, masses are same. है ना students? So can I get u equal to v1 plus v2? Students, they are in vectors. They are in vectors. Don't you think so? This is triangle law of vector addition. आया कि नहीं आया? Law of conservation of linear momentum से. ये देखो, v2 bar, v1 bar, u bar, tail head, tail of the first vector, the head of the second vector. आ गया तुम्हारा. Students, अभी क्लियर हुआ कि नहीं हुआ, या अभी भी क्लियर नहीं हुआ?
Yes.
और ये मोमेंटम इज अ वेक्टर क्वांटिटी. स्टूडेंट्स, काइनेटिक एनर्जी के टाइम पे मैं क्या एरो डालता था? नहीं डालता था ना. यहाँ पे मोमेंटम कंजर्व हो रहा है, तो ये तो आ ही गया तुम्हारा. इज दिस क्लियर टू ऑल ऑफ यू ऑल? अभी क्लियर हुआ व्हाट मीन मी टू राइट डाउन माय पैरेललोग्राम लॉ ऑफ वेक्टर एडिशन? या ना, इज इट क्लियर? आई एम आस्किंग यू.
सर पर cos θ1 plus θ2 क्यों है? It has to be only θ2, right?
Oh my God in heaven above, keep thy feet, be thy love, with thy children, pray to you, amen. Sanjana, don't laugh. Swani, don't laugh. ये देखो ना, V1
Yes, sir.
V2 वेक्टर्स ना, ये देखो ना, ये तो वेक्टर्स है ना. या ना, क्या कर रही है तू? इन दोनों के बीच में एंगल लिया है ना. ये तो मैंने ट्रायंगल लॉ ये शिफ्ट कर दिया है. भूल गई तो पैरेललोग्राम लॉ ऑफ वेक्टर एडिशन. द टू वेक्टर्स आर इंटरसेक्टिंग एट द टेल, रिजल्ट इन इस डायरेक्शन जा रहा है. तो वही अगर मैं ट्रायंगल लॉ में लिखूंगा, तो यहाँ पे मैंने इसको शिफ्ट कर दिया है. ये वेक्टर को मैंने शिफ्ट कर दिया है. एंगल तो टोटली आएगा ना, θ1 प्लस θ2, है ना. डोंट मेक मी टू क्राई. है ना, है ना, जल्दी बोलो.
हाँ ठीक है.
हाँ या ना.
हाँ
क्वेश्चन क्या है ना? तुम्हारा ये वेक्टर, ये p वेक्टर यहाँ पे जा रहा है, q वेक्टर यहाँ पे जा रहा है, रिजल्टेंट r वेक्टर. So r square is equal to p square plus q square plus 2pq cos entire angle between them. What is the entire angle between them? Theta 2 and theta 1. Theta 2 is the angle of what? Of the target ball with the horizontal. Theta 1 is the angle of the cue ball with the horizontal. हमें theta 1 पूछा गया है. Now can I say, students, can I go for conservation of energy also? Why not? What exactly conservation of energy, students? Half m u square initial, इसका तो 0 है ना? What is the final energy? Sir, it's half m v1 square plus half m v2 square. दोनों का मास सेम है. ये law of conservation of energy है. ये हुआ law of conservation of linear momentum. I'm putting it over here, students. Half m u square is equal to half m v1 square plus half m v2 square. Friends, from here, can I say u square is equal to v1 square plus v2 square? Ayana?
Yes.
Friends, so उससे तुम्हें पता चला what is the angle between the two vectors? Angle between the two vectors. This should be 90. Cos of 90 will be 0. आ गया ना तुम्हारा आंसर? ये देखो. ओ यानी सर, अगर इसको तुम्हें यहाँ पे अगर मैच, अगर इसको तुम मैच, सिंपल वेक्टर्स है, u स्क्वायर इज इक्वल टू v1 स्क्वायर प्लस v2 स्क्वायर, तो ये क्या हो जाएगा? ये तो 0 होना चाहिए, है ना? ये 0 कभी होगा? जब ये 90 डिग्री होगा. अगर ये 90 डिग्री हुआ, ये अगर टोटल 90 डिग्री हो गया, टोटल 90 डिग्री होगा, और ये 37 दिया है, तो व्हाट इज द एंगल ऑफ द क्यू बॉल विद थीटा 1? आंसर इज 53. आ गया तुम्हारा आंसर 53. और अगर तुम्हें सॉल्व भी करना तो करो ना, यू स्क्वायर को भी यहाँ पे सब्स्टिट्यूट करो. यू स्क्वायर को वैसे रखो. व्हाट इज v1 स्क्वायर प्लस v2 स्क्वायर? व्हाट इज u स्क्वायर प्लस 2v1 v2 cos of theta 1 plus theta 2. Students who doesn't want to click it in that case, स्टूडेंट्स को जिसको कनेक्ट नहीं होता है तुरंत, उनके लिए मैं सॉल्व कर रहा हूँ. ये कैंसिल हो जाएगा दोनों तरफ. तो कैन आई से 2v1 v2 cos of theta will be equal to 0. 2v1 v2 cos of theta 1 plus theta 2 will be equal to 0. What is cos of 0? Cos of pi by 2. तो कैन आई से ये तो 0 हो जाएगा. पहले मैं ये लिखूंगा, ये 0 हो जाएगा. तो कैन आई से cos of theta 1 plus theta 2 will be equal to cos of 90 degree. So can I say theta 1 कितना दिया पूछा गया है, theta 2 कितना दिया 37. So can I say theta 1 will be equal to how much? 90 minus 37. What's my answer? 53. क्या ये क्लियर हुआ?
सर आप पूरा प्लीज एक बार रिपीट कर दोगे?
अरे यार याना, क्या रिपीट, कहाँ से करूं मैं रिपीट? बोलो. तुम्हें वेक्टर समझ में नहीं आया है ना?
सर आफ्टर दैट आई लॉस्ट माय कनेक्शन.
वेरी गुड. ये देखो ना, ये देखो ना, ये वेक्टर इस तरफ जा रहा है, ये वेक्टर इस तरफ जा रहा है. दोनों के बीच में एंगल थीटा 1 प्लस थीटा 2 है. तो मैंने क्या किया, मैंने तुम्हें एक पैरेललोग्राम लॉ ऑफ वेक्टर एडिशन के हिसाब से दे दिया. लेकिन यहाँ पे आने के बाद में फिर स्टूडेंट्स कहेंगे सर आपने ये कैसा लिख दिया? तो मैं वापस लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम पे चला गया. और वहां पे तुम देखोगे तो लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम बीइंग अ वेक्टर क्वांटिटी v1 बार प्लस v2 बार इज इक्वल टू u बार. तो मतलब हाँ सर, v1 बार प्लस v2 बार इज इक्वल टू u बार. तो अगर मैं पैरेललोग्राम लॉ ऑफ वेक्टर एडिशन करूंगा तो मेरा फॉर्मूला यही आएगा. फिर मैंने क्या किया, काइनेटिक एनर्जी को कंजर्व किया. हाफ एम यू स्क्वायर, ये तो रेस्ट पे है, इसका हाफ एम v1 स्क्वायर होगा, ये हाफ एम v2 स्क्वायर होगा. हाफ एम कैंसिल हो जाता है दोनों तरफ. व्हाट इज v1 स्क्वायर प्लस v2 स्क्वायर इज इक्वल टू u स्क्वायर. कैन आई सब्स्टिट्यूट v1 स्क्वायर प्लस v2 स्क्वायर एज u स्क्वायर हो गया? यस. तो ये भी u स्क्वायर था और ये भी u स्क्वायर है, और ये इक्वल टू साइन वो कैंसिल हो गया. तो 2v1 v2 cos of theta 1 plus theta 2 will be equal to 0. So can I say cos of theta 1 plus theta 2 is equal to 0 and cos of 90 will be equal to 0. है ना? So what is theta 1 plus theta 2 is 90. How much is theta 2 is given to us? 37. So what is theta 1? 90 minus 37. What's your answer? 53. So what is the angle formed by the cue ball with the line of impact? 53 degrees. Is this clear, Yana?
Yes sir.
Fine, friends. Next lectures will be continuing with the problems. Next lecture will be solving some more problems onto this. And mostly this will be a completion of the chapter, students, okay? And then we'll be going with respect to your rotational motion, students. Okay?
Okay.